that actually run the Festo line over there. You know, the first class we went over there to and looked at the Amatro line and the Festo line.
Festo was the second.
Huh?
That was the second.
Yeah, the Festo line was the one that put together the cylinders, and the Amatro line's the one that put together, it's the newest one, it put together the directional control valve. Now these are the actual prints that come with the line. So this is RS Logix. Well, it's in German and English. There should be several different things. So, of course, Festo is a German company. So, most of the stuff that they show us is in German. But you can see the way this thing works is that we have 7 modules over there. And a lot of the routines that they do are exactly the same. Their address is the same. You know, they have one PLC per module. And they all have start, they all have stop, they all do this, and they all do that. So what normally we take when we come up and we have an extremely big program, it gets almost impossible to actually edit the program. Because you have to go out and you have to find a rung, you have to find a section in a PLC. Like Vincent was talking about something they had out there, almost 3,000 rungs in the program. Okay, the rubber mill, 3,000 rungs. And if they put that sucker in one program, then we really got problems. Just what? Finding where it's at. Larry said it's not
No.
Oh, we did just get a break.
I was looking, this little JIT program you use, look at their emergency stop.
What?
They've got a normal code symbol for their emergency stop.
What, this guy?
Yeah.
Oh, yeah, so they got an examiner. Yeah, sometimes so you're right, and it's a normally open push button. You go over to the Amatron line, and we look at that, and they're doing they're using the normal button, they're using the examiner. They do, the Amatron has an e-stop button, and it's a normal button. So if we look at the Amatron line, that would be drawn as an example close. This guy right here is so you're right.
That was just first thing that caught my eye.
Don't look like that. I don't know how that could be an e-stop button. Tell you the truth. Why can't it be an e-stop? I think they just mislabeled it. Why can't it be an e-stop? Because they got something in parallel with it. I think they probably just, you listen to me, Larry, I don't think that thing's got an e-stop button on it.
Really?
No, it don't. I mean, it's got a stop button, but it's not an e-stop. If you get over on the Amatron line and you hit that e-stop button, it's gonna kick off the whole line. This right here just stops that section, and it's not an e-stop because of one thing. I've never seen this before. Yeah, we bypass an e-stop. So it looks like they're using a stop button, a normally open stop button, because all the buttons on that is a stop. But that's not what we're talking about. No, we're talking about that. So what JSR does for jump subroutines, it allows us to take an extremely large program and break it down in modules.
That's chapter 2. That's what we want.
That's what we got an hour, we don't have time to allow, so we'll just get an introduction. We'll split out about one. So this is a programmer's dream right here. We call these structured programs, where basically the way it's set up is you primarily have what we call a main module or main program. Then what does it do? It loads in subroutines.
Now, if you have the jump to subroutine, can you click on that link and it automatically take you to it, or do you still have to manually find that link?
No, what happens on Allen Bradley, this is not what's going on here. You can definitely see it on Logic Pro. You can't see it on this guy right here because we're not loading in the whole thing. But when you go to Logic Pro, let's see if I have it running instead of running, is what you notice down at the very bottom. We have ladder 2, which is the primary. That would always have to be your main. And then we see tabs across SPR, 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 SPR. So what happens with the Allen Bradley is that when you build a subroutine, you get a new tab down at the bottom. And then what you can do to go between the subroutines, and notice the subroutines have numbers, 1, 2, 3. So here we might say jump subroutine 1. And then if I wanted to see what was in that subroutine, I'd just go down to the bottom tab and just go through that. So that's a really good question. In programming, what we do is we give subroutines names. We split the sections up. Or we can do one of two things. A lot of times in programming, the subroutines are actually never loaded into memory until you need them. Windows calls them data link libraries. If you've got the Windows operating system on your computer, and you go into the folder options and you tell it to view file extensions, and you start looking for .dlls, those are subroutines. And what's nice about subroutines, if they're not in the memory of the computer, is any program can use them. So what that means is that any program can call a subroutine. So how many applications in Windows do you use that uses spell check? Well, how many programs actually write the spell check program? Hardly none of them, because those are basic subroutines as part of Office, right? You understand? So instead of me doing a spell check on my email, they can use the what? They can use the subroutine that's already written to do spell check, which is pretty nice. So, but what's nice in PLCs is these programs get so dang big. You know, we're playing around with little old tiny programs. We say, how many rooms you got? Well, I got 9 rooms. You know, we're talking about, you get out there to, you know, like US Steel, these big companies, and you're talking about these ladder logic programs are thousands of rooms. And I can show y'all, I need to run that off for you too. Is some of the prints for US Steel where they actually work. We think about in motor control, we think about this one little circuit we got up there on the board, but when you start looking at these prints at US Steel, you've got hundreds of runs, right? Or thousands of runs. And so they have to split them up. So they split them up and put them on different drawings. Well, that would be basically the same as a subroutine. So what we can do is we can take an extremely large program and split it into submodules, which we call subroutines. And then that way, if I want the subroutine that does this, instead of me trying to find it in that one scan, right, understand, I can do what? I can go directly to that subroutine. I can change the timer. I can do counters. I can modify it. I can add a run. I can change a run. It does not affect anything else in any other module. Right? You understand? So that means I've got all these runs down, and I say, okay, run 15 does this, run 16 does that. And then I come in there and I insert a run, and what just happened? All my run numbers change. Right? You understand? Well, what's nice about subroutines is that it has nothing to do with the other subroutines, right? You understand? So what can we do? We could add another subroutine. I thought we could. We can modify a subroutine and not affect the other one. Subroutines. Look at this program. The very first thing they do is a what? Open on program. So this is the sure enough program. The very first thing they do in this program is do what? Very first instruction.
First thing? Oh,
Four. Yeah. Jump subroutine 6. Straight down. This guy here. So subroutines are considered what type of instruction? Output instruction. Yeah. So they're output instruction. Well, here, this guy here is what we call an unconditional jump. So notice there's no decision making. So every time it hits run 1, it's going to do this sub. Of course, we have to find that subroutine. I don't see any tabs. It didn't come up. The tabs didn't come up. Jump subroutine. Then it comes down here, and 2 is a what? Yeah, it's a subroutine though. Yeah, and then down here we got this is our first true, and it's a bit file too. Well, here's a latch, unlatch. Here's an unlatch. Here's a latch, unlatch. So there's a latch and relay that they got. So you can use latch and relays for sealing circuits, right? OSR, have to look that up. Oh, this is one shot. So that's a one shot. So what's a one shot? I don't know if we have time to get into this. Yeah, but a one shot means when it's energized, it goes true for a certain amount of time, and then it does what? Goes false. Yeah, really neat.
It's just a false, right?
Yeah, it's false.
One box, right? No.
But look, mainly this is just what? So this would be our main loop for running that module. And then basically all it does is just do what? Well, calls other what? Subroutines. So I'd have to find those subroutines, guys. I don't know how these look like they're actually called up from somewhere else. Normally when we put subroutines, we get multiple tabs across the bottom, one for each subroutine.
So that subroutine file number U semicolon 4 is supposed to go find that particular file.
Yeah. And then it runs that.
That's really how I keep clicking that.
No, don't think so. I just deleted it. So no, don't click on it. Yeah. Of course, it gave us an E. Logic Pro would not give you any errors at all, right? Which is what's the problem is. Let's see if we. Let's say I'm not going to. No. Now none of these are bringing in the subroutines with them that I can see. Oh yeah, thank you. So ladder 2, ladder 3. So there it is. So now it added the tab. Thank you, Larry. I couldn't remember.
There's your arrows where it extends your run.
Yeah, this. Oh yeah, so this one I got it blown up so big.
Yeah.
So if you eventually if you keep making it so people can see, it'll drop down. This is still the same run, right? Yeah, so I'm gonna come up here and add these tabs. So e-stop here and here. So notice when I open them up, of course ladder 2 is your main program, right? Yeah, so the tabs pop up. So let's see what's at the bottom of this. So this should be a subroutine here. Yeah, that's what I was looking for. So the final instruction in a subroutine should be what?
Return.
So JSRs and returns, these are what we call instruction pairs, which means what? You gotta have both. So what we do is we give a subroutine a name, and then we call that subroutine, and then when it gets through, it returns, and once it hits return, what we do? Well, it goes back to the run, it goes back to the next run. We'll have to figure out how they name them. So here's my main rung. So this is going to jump to a subroutine, right? Y'all understand that? And then it goes back, and the last statement in this subroutine would be a what? Return. And then it would come back and do what? Run 2. And then this would go out and jump to a subroutine U5. And then what would it do when it hits that return?
Jump up 03.
It would come back and scan rung 03. So return brings it back to the next rung immediately after the return. Immediately after the jump. We'll have to figure out how they do the names, because down here, they actually have the names of the subroutine. So you can rename these tabs. I'll figure out how they do, how they're specifying which subroutine that's there. Oh no, they give you the name. So stop, P-stop. So this right here would call this subroutine. Right. See what I'm talking about? Right.
So, we used to, I can't remember, it's on this side over here, and there was a spot we used to click on, and it would carry us from like, if I wanted to go to entry in, I just hit entry in.
Yeah, well, that's the same thing. See, so here's all your ladders. Here's all your subroutine. Ladder 2 is always your what?
Original.
That's the main program. And then every one of your subroutines will appear over there.
So it's like chapters of the book.
Right. Well,
Full content.
yeah, they could take everything that's in your book, right, and just write it from start to finish. Then it would be hard to find stuff.
That's why we're saying, if you have a program that's real long, and you gotta sit there and scroll down, and try to find it. You use the subroutine and say, hey, take me to the entry.
The part of the program that runs the entry, or the part of the program that runs the exiting, or the part of the program that runs the middle end, right? Or some of them that does the furnace, some of them that does
the
this.
wells.
So what you do now, instead of trying to find that in a long ladder diagram, you can go directly to that module that does all, that controls that section. So if you don't write in subroutines, then believe me, I've been into those programs before, and it's almost impossible to find stuff.
You can't, well, down there, you can't search for a contact. Or like, you have the nickname a lot, or register. And it will take you can do it globally. Throughout the whole thing.
That's not something I know how to do. I can look at it. I don't know if there's a search feature up at the top. Is there?
You can search the output.
I think on RS-5000.
Yeah, we do have RS5. We have Factory Talk. We have RS5000. It's just that the PLCs that we got don't support that language. But we do have some.
It's like if we were doing input, we have to do a search, because that input be running so many things. And so you want to make sure if you're going to change the symbol of the input, you got to make sure what else is running, because if you change it on one end, it's going to change on the other.
And another thing that I don't know how to do with the PLC, if y'all can figure it out, is on ladder diagrams, what we put over here on the right-hand side is we put what we call cross-reference numbers that identifies where the contacts are at. PLC, I don't know if you can print it and have it do the cross-reference numbers for you or not, but that really, really helps. But I don't see a search in 500.
Up that top. That search.
Slide to space.
You search.
Right. Slide right. One more. Right here.
When you say find, you type in.
But it's already looking for you. U5. So this would, I don't know if it does the subroutine. Let's find,
Find all. Yeah, hit find all.
okay, so let's find a contact. Let's look for a contact in this subroutine right here. I'll put 0, 0.
Type it in. I got that.
Sorry.
OPP.
Yeah, okay. Okay, sorry.
Or you can say, I think you should have that.
They can't.
Yeah, here's,
You got one on 3, one on 3, one on 5. They tell you what you got to examine it close. Yeah, no problem. Okay.
Because that where it says scope globally, I think Richard.
where? Oh, right here. Let's go below.
If you click on, that's another extreme, or what is that word? Local, it'll be right in,
It'll be inside the ladder you're in. If you say global, it's gonna do all subroutine.
program. Then you can go down or up, you can back it up, and what that's good for, sometimes you have something that's acting a fool like that, a contact, right?
Not a person.
Well, I mean, you got this one contact that's acting a fool, and so instead of forcing it, I forgot the word is, but, you can change that one contact that you need to get this portion of it to work. But you gotta write it down so the engineers can figure out what's going on. It's not a force, it's just forcing. It's like, you got output 0 and 1, 2, 3, 4 spots. But just say, run 29 is acting a fool. You can go to 129 and do what you have to do, and the program will work just like it is.
Let's say, this is what's needed too, so you can come in here and click on this list and it takes you to that location.
You would go there and change it. Give it a little address and then they'll come back.
So undoubtedly, I don't,
Change one address.
No, it's a certain thing that you can do. It's not changing all. You just change, and it sits there and plays. When you, no. You just go in there, instead of it being remote, you may change the remote flow just to get it to work that time.
Yeah.
But it doesn't affect none of them.
The address is thing, it'll affect all
I'm
of them.
telling you, it does that on that one there too.
Yeah, if you change.
That's why you would do it local.
That's simple. Yeah.
I don't think on Logic Pro, I don't think you can change the name of the tabs.
Well, it says, ladder 3 dash P original. I'm sorry, ladder 2.
No, I said Logic Pro, not here. This is RS Logic.
Said Logic Pro. Your little thing.
I think on Logic Pro, I'm not sure, but I think it already puts you so many subroutines down there. I don't know how many, I think, in fact, I know, Allen Bradley or RS500 or RS Logic 500 supports 256 of them. Seems like a lot.
How big?
3,000 lines of code, I imagine there's quite a few subroutines in there. Okay, guys, so what's the plan for Wednesday?
Make 100 on the test.
Start off where? Start off in lab, and then we'll switch over to the not at 9:30.
2 hours.
So let's start at what? 11:30.
Early as possible.
Give y'all 2 hours to take tests. I can't remember how many questions are on there, but there's a few.
That's gonna be at the beginning of the class, or just?
No, what we do is what I do for test 1 and 2, we give it at the end of the class, and why do I like to give it at the end of the class? Well, it's for y'all, it's not for me. I have to stay here 2 o'clock anyway. So we give that, so if you get through the test early, you can do what? You go. If I gave it at the start of class, then if you got through early, what would you have to do? You'd have to hang around, right? Well, yeah, we don't like to do labs when tests are in progress. So. All right, guys, we're through. Unless some of y'all want some other questions.
Like on this one, our page number was wrong, so our page number's on the next one.
No, some of these might be wrong. The problem is when I was going through my lab book, this is something I added this time. And sometimes I got the Logic Pro labs confused with the RS Logic labs. And I didn't put a 6, so I'm going to give y'all the new version of this. This one's right, though. This is better. I'm going to give y'all a new one.
But it's not on, it wouldn't be on 211. That'll be in our lab book, right?
I don't know.
I'm trying to page 211, it's at the end of a lab.
It's a whole lab, so we're doing this. There's no activity here because it's a whole lab. Is that what you saw in your lab book?
Yeah, I saw this right here.
Yeah, this is what you need to turn in.
Okay.
Well, what you're going to do is you're going to do a ladder. You're going to do a ladder diagram for each one of the instructions. So we're adding a little more on Logic Pro. So here you're supposed to draw them, but I'm going to ask you to do it also in Logic Pro.
The math instruction.
Yeah, each one math instructions.
Okay.
Now, why we're not going to do a bunch of sections in here is because a lot of the labs we're going to do later on requires the math instruction. So we're not going to do a lot of math instruction. In fact, I think we're going to do, so your compare instructions use math instructions too. Does that make sense?
So this is what I use this on, is ProLogic on the disk.
Yeah.
And do me some runs with the different math instructions.
Right. Each one of these. So each one of these, I want a little program for each one of these.
Okay, multiplication.
Addition, subtraction, multiplication, and division. That's all I asked you to do. But the page number's right on that one.
Okay, that's good.
Okay, so that's in where chapter 10. What chapter is that in?
The math instruction.
Chapter 10. Okay.
Add, subtract, multiply, and divide.
So that's what we
No
got.
trig.
Okay.
The 1100 PLC don't even support the trig functions.
See you tomorrow.
Okie dokie. Oh, there it is.